Hey everyone, welcome back to our channel. If you're new here, don't forget to hit that subscribe button and the bell icon so you won't miss our future videos. Let's get started. Describe your approach to efficiently loading data into Snowflake from various sources.
I would utilize Snowflake's native support for semi-structured data formats like JSON, XML, and Parquet, and leverage Snowpipe for continuous data ingestion. Additionally, I would consider using external tables to query data directly from cloud storage without loading it into Snowflake. Here's an example query.
How do you ensure data security and implement access controls in Snowflake?
I would leverage Snowflake's role-based access control, RBC, to assign granular permissions to users and roles. Additionally, I would enable multi-factor authentication, MFA, for enhanced security and use Snowflake's native encryption capabilities to protect sensitive data at rest and in transit. Here's an example query.
How do you identify and troubleshoot performance issues in Snowflake?
I start by analyzing query execution plans using Snowflake's query profiling tools to identify bottlenecks. I also monitor warehouse usage and resource utilization metrics to adjust warehouse sizes and concurrency settings accordingly. Additionally, I may optimize SQL queries by rewriting them to leverage query hints or adjusting join strategies. Here's an example query.
How would you optimize the performance of a Snowflake database when dealing with large data sets?
One approach would be to partition tables based on key columns to distribute the data evenly across clusters. Additionally, using clustering keys can further improve query performance by physically organizing data based on common attributes. Here's an example query.
How would you design a system in Snowflake to support real-time analytics and reporting?
I would use Snowflake Streams feature to capture real-time data changes from source systems. Then, I'd set up continuous ingestion pipelines using Snowpipe to load data into staging tables. From there, I'd leverage materialized views or scheduled tasks to aggregate and summarize the data for reporting purposes. Here's an example query.
Describe the architecture you would recommend for a scalable data warehousing solution using Snowflake.
I would design a multi-cluster Snowflake architecture with separate compute clusters for different workloads such as ETL, data transformation, and analytics. Each cluster can be scaled independently based on workload requirements, and I would use virtual warehouses to isolate resource usage and optimize performance. Here's an example query.
How do you enforce data governance policies and ensure data quality in Snowflake?
I would implement data governance policies using Snowflake's metadata management features, such as tagging objects with business metadata and defining data classifications. Additionally, I'd leverage Snowflake's data sharing capabilities to enforce data lineage and facilitate collaboration between different teams. Here's an example query.
What strategies would you employ to ensure high availability and disaster recovery in Snowflake?
I would replicate data across multiple regions using Snowflake's cross-region replication feature to ensure data redundancy and disaster recovery. Additionally, I'd regularly back up critical data using Snowflake's time travel and clone features to minimize downtime in case of data corruption or loss. Here's an example query.
How do you optimize costs while using Snowflake, especially in a cloud environment?
I would regularly monitor and analyze usage patterns using Snowflake's usage reports and billing information to identify cost-saving opportunities. This may involve resizing warehouses, optimizing queries, and leveraging features like auto-suspend and auto-resume to minimize idle time and resource usage. Here's an example query.
How do you work with semi-structured data formats like JSON or XML in Snowflake?
Snowflake natively supports semi-structured data formats, allowing us to store, query, and process data in JSON, XML, or Parquet formats. We can leverage Snowflake's variant data type for JSON data and XML parsing functions for XML data to extract and manipulate relevant information. Here's an example query.
Explain how you would perform cross-database queries in Snowflake.
To perform cross-database queries in Snowflake, we can qualify table names with the database name followed by a period. Additionally, we need appropriate privileges to access objects in other databases, either by granting privileges directly or through roles. Here's an example query.
How does Snowflake's time travel feature work, and when would you use it?
Snowflake's time travel feature allows us to query historical versions of data stored in tables for a specified period. We can use it to recover from accidental data modifications, perform audits, or analyze data changes over time without needing to restore backups. Here's an example query.
Describe how you would implement workload management in Snowflake to prioritize critical workloads.
In Snowflake, we can define workload management policies to allocate resources based on workload priorities and user-defined criteria. We can specify concurrency limits, query priorities, and resource utilization thresholds to ensure that critical workloads receive adequate resources. Here's an example query.
How would you use Snowflake's data sharing feature to share data with external parties securely?
Snowflake's data sharing feature allows us to securely share data across accounts and organizations without copying or moving data. We can create share objects to grant access to specific datasets, and consumers can query shared data as if it were local to their own account. Here's an example query.
Describe how you integrate Snowflake into a CI or CD pipeline for automated testing, deployment, and version control.
We can integrate Snowflake into CI or CD pipelines using Snowflake SQL commands, Snowflake REST APIs, or third-party CI or CD tools like Jenkins or GitLab CI. We can automate database deployments, execute SQL scripts for schema migrations, and perform data validation tests as part of the CI or CD workflow to ensure reliable and efficient software delivery. Here's an example query.
How do you implement data masking and obfuscation techniques in Snowflake to protect sensitive information?
Snowflake supports data masking through dynamic data masking policies and functions like masking_policy. We can define masking rules to redact or obfuscate sensitive data based on user roles or access privileges, ensuring that only authorized users can view or access masked data. Here's an example query.
Explain how you perform geospatial analysis in Snowflake to analyze spatial data or location-based information.
Snowflake provides native support for geospatial data types and functions, allowing us to perform various geospatial operations like distance calculations, point and polygon checks, and spatial joins. We can store geospatial data as variant columns or use specialized formats like well-known text, WKT, or well-known binary, WKB, for spatial data representation. Here's an example query.
How do you implement data masking and obfuscation techniques in Snowflake to protect sensitive information?
Snowflake supports data masking through dynamic data masking policies and functions like masking_policy. We can define masking rules to redact or obfuscate sensitive data based on user roles or access privileges, ensuring that only authorized users can view or access masked data. Here's an example query.
Explain how you perform geospatial analysis in Snowflake to analyze spatial data or location-based information.
Snowflake provides native support for geospatial data types and functions, allowing us to perform various geospatial operations like distance calculations, point and polygon checks, and spatial joins. We can store geospatial data as variant columns or use specialized formats like well-known text, WKT, or well-known binary, WKB, for spatial data representation. Here's an example query.
How do you handle schema changes and versioning in Snowflake to accommodate evolving data requirements?
Snowflake's schema on-read architecture allows for flexible schema evolution without impacting existing data. We can easily alter tables to add or modify columns, and Snowflake automatically handles schema changes during query execution. We can also use schema versioning techniques or schema evolution scripts to manage changes systematically. Here's an example query.
How do you replicate data between Snowflake accounts or regions for disaster recovery or data consolidation purposes?
Snowflake supports data replication through features like cross-region replication and data sharing. Cross-region replication allows us to automatically replicate data between Snowflake regions for disaster recovery, while data sharing enables sharing data securely across accounts for data consolidation or collaboration purposes. Here's an example query.
Describe how you can extend Snowflake's functionality using external functions and integrations.
Snowflake supports integration with external systems and services through external functions, allowing us to execute code written in other programming languages, e.g., Python, Java, or call external APIs directly from SQL queries. This enables advanced data processing, machine learning model inference, and integration with third-party tools and services. Here's an example query.
How do you manage metadata and data dictionaries in Snowflake to document data assets and improve data discoverability?
Snowflake provides metadata management capabilities through information schema views and system tables, allowing us to query metadata about databases, tables, columns, and other objects. We can also leverage external metadata management tools or custom solutions to automate metadata extraction, documentation, and lineage tracking. Here's an example query.
Explain how you would enable and use audit logging in Snowflake for compliance and security purposes.
Snowflake's audit logging feature captures detailed information about user activity, including login attempts, SQL queries, and data access. We can enable audit logging at the account level and configure it to log specific events or activities. Audit logs can then be analyzed for compliance audits, security investigations, and performance monitoring. Here's an example query.
How do you perform complex data transformations within Snowflake?
I typically use Snowflake's built-in functions and SQL capabilities for data transformations. For more complex transformations, I may write JavaScript UDFs, user-defined functions, or leverage Snowflake's integration with external libraries like Apache Spark or Python. Here is an example query.
How do you handle time zone conversions and differences in Snowflake?
Snowflake supports time zone conversions using built-in functions like convert_timezone and timestamp_tz. When querying timestamp data, we can specify the desired time zone for accurate results. It's essential to consider time zone differences when dealing with global data or scheduling tasks across different regions. Here's an example query.
How do you ensure data security through encryption in Snowflake?
Snowflake provides robust encryption options to protect data both at rest and in transit. We can enable automatic encryption for all data stored in Snowflake, configure client-side encryption for additional security during data ingestion and extraction, and use SSL or TLS encryption for secure communication between clients and Snowflake. Here's an example query.
How would you use Snowflake's data sharing feature to share data with external parties securely?
Snowflake's data sharing feature allows us to securely share data across accounts and organizations without copying or moving data. We can create share objects to grant access to specific datasets, and consumers can query shared data as if it were local to their own account. Here's an example query.
Describe how you would implement workload management in Snowflake to prioritize critical workloads.
In Snowflake, we can define workload management policies to allocate resources based on workload priorities and user-defined criteria. We can specify concurrency limits, query priorities, and resource utilization thresholds to ensure that critical workloads receive adequate resources. Here's an example query.
How does Snowflake's time travel feature work, and when would you use it?
Snowflake's time travel feature allows us to query historical versions of data stored in tables for a specified period. We can use it to recover from accidental data modifications, perform audits, or analyze data changes over time without needing to restore backups. Here's an example query.
Explain how you would perform cross-database queries in Snowflake.
To perform cross-database queries in Snowflake, we can qualify table names with the database name followed by a period. Additionally, we need appropriate privileges to access objects in other databases, either by granting privileges directly or through roles. Here's an example query.
How would you efficiently store and query large textual data, such as documents or logs, in Snowflake?
Snowflake provides support for storing large textual data using its variant data type or by leveraging its semi-structured data capabilities for JSON or XML documents. We can use Snowflake's text parsing functions and full-text search capabilities to query and analyze textual data efficiently. Here's an example query.
Describe how you would implement near real-time data processing and analytics in Snowflake.
We can achieve near real-time data processing in Snowflake by integrating with streaming data sources using Snowpipe or external streaming services like Kafka. We can then use Snowflake's continuous ingestion capabilities and materialized views to process and analyze streaming data with minimal latency. Here's an example query.
How do you optimize query performance when dealing with complex join operations in Snowflake?
To optimize query performance for join operations in Snowflake, we can use clustering keys or sort keys to organize data and minimize data shuffling during joins. We can also leverage query optimization techniques like query hints, parallel processing, and partition pruning to improve query execution time. Here's an example query.
How do you implement data archiving and retention policies in Snowflake to manage storage costs and compliance requirements?
We can implement data archiving and retention policies in Snowflake using time travel, data cloning, and table partitioning features. We can configure automatic data retention policies to archive or delete historical data after a specified period, reducing storage costs and ensuring compliance with data retention regulations. Here's an example query.
Explain how you would analyze and optimize query performance in Snowflake using query profiling and monitoring tools.
Snowflake provides comprehensive query profiling and monitoring tools like query history, query profile, and query execution details, which allow us to analyze query performance metrics such as execution time, resource usage, and query plans. We can use this information to identify performance bottlenecks and optimize queries by adjusting warehouse sizes, query hints, or schema design. Here's an example query.
How would you implement incremental data loading from source systems into Snowflake to minimize processing time and resource usage?
We can implement incremental data loading in Snowflake by using change data capture, CDC, mechanisms or timestamp-based filtering to identify and load only the new or modified data since the last load. We can then use merge operations or upserts to synchronize the incremental data with the target tables in Snowflake. Here's an example query.
How do you perform data sampling and analysis in Snowflake to understand data distributions and characteristics?
Snowflake provides sampling functions like sample and tble, which allow us to extract random or stratified samples from large datasets for analysis. We can use these samples to estimate data distributions, identify outliers, and validate assumptions before running analyses on the entire dataset. Here's an example query.
Explain how you would store and analyze time series data in Snowflake for applications like IoT, monitoring, or financial analysis.
Snowflake supports storing and analyzing time series data using timestamp data types and time-related functions. We can partition tables by time intervals, use time window functions for calculating aggregates over time periods, and leverage Snowflake's time travel and clustering features for efficient time series data management and analysis. Here's an example query.
How do you implement row-level security in Snowflake to restrict access to sensitive data based on user roles or attributes?
Snowflake provides row-level security, RLS, through dynamic row access policies, allowing us to control access to rows and tables based on user attributes or conditions. We can define predicate expressions in RLS policies to filter rows based on user roles, attributes, or external data sources, ensuring that users only have access to authorized data rows. Here's an example query.
Describe how you would integrate Snowflake with external BI tools or data visualization platforms for reporting and analytics.
Snowflake provides native integrations with popular BI tools like Tableau, Power BI, and Looker through JDBC or ODBC connectors and Snowflake's native SQL interface. We can connect BI tools to Snowflake using standard connection parameters and SQL syntax, enabling seamless data access and visualization for reporting and analytics. Here's an example query.
And that's it for today's video. If you found this video helpful, please give it a thumbs up and share it with your friends. Don't forget to leave your comments below. Thanks for watching, and we'll see you in the next video.